Yes, hello, good morning from my side. Thank you for Katharina to open the stage and with nice information and discussion. I will bring in today a little bit different viewpoint to the story. And you could see it here. It will maybe not go too much in technical detail, but it will give you some more, hopefully, inspirations how future development will look like also in the energy system area. So also a short slide, engineering service provider, EDAG as well, doing, let me say, full vehicle development, founded 1969, 9,000 people globally. And we are doing vehicle and industry engineering, electronics, also manufacturing, planning, and as well software and digitalization. Where we start from, let me say, the energy system, we see it as an ecosystem which combines low voltage, high voltage, but also, let me say, the energy system, because vehicles, with vehicle to grid, going into a net or going into the grid will be part of this, and that is the complex ecosystem you have to deal with and you have to handle. And how we would like to approach this, and so what hurdles we have or what items we have, I think it's all known. So from a cost pressure, from time to market, from inefficiencies we have over all the systems, we have to find ways to do this better. And one approach is increasing the engineering process, and that's exactly where we're coming from a component level, from standards, from manual work, digitalize it, automate it, finally connect, which is also really an important point, connect, and I mean really connect the processes, and then orchestrate, and I will let you know what I mean with that. And now it gets a little bit fancy and not technical, because we all talk about the software-defined vehicle, for example, and we still talk about component optimization. And from our and my perspective, it's really a mindset change you need, thinking about processes, thinking how you would like to develop certain systems and applications. And it's also organization, quite probably, you have to adjust to this. And therefore, we use the well-known V model and call it in our way diamond model, because it's so important that you have really the customer function in mind in order to have an efficient system. And just as an example, so if I tell our engineers, give me a battery, I will get a battery. But I need energy content in a certain application, and it could be different. Maybe it's the battery, maybe it's the Marvel famous Jarvis fusion reactor in some time, whatever. But you have to be open from the beginning, and you have to focus what you would like to deliver for your application. And to do so, and therefore AI is maybe the smallest part in my presentation, and there's a lot of buzzwords right now. First of all, you have to understand your component, and that's what you showed and what we see here in many presentations, and that's the baseline. You have to understand this. And the second is you have to digitalize this, and you have to get your processes right. So you have to understand what is behind. So, and you all know there are so many complicated systems and components, but complicate you can rule-based transfer in a digital system. And that's what you have to do, and you have to do this on every single layer of your different process or on your different items, from the requirement definition down to the software and then up to the testing, and then confirming that you really get what you would like to have on a feature. So, and exactly with that, and if you have this, and that was quite probably also an important point I didn't mention, responsibility, end-to-end responsibility, that you have a function and that you really look from the beginning to the end that you are responsible for and have then also the rights and the empowerment to decide for your function what needs to be done. And if you combine this, that is the big benefit. Exactly, it tackles the hurdles we have. Then you see really an optimized energy efficiency on a system level, not on a component level, and also that is what we said. So quite probably a lower roof line is much more efficient than the 1% of powertrain. And don't say that the powertrain 1% is not important, it is. But you have to combine it, and sometimes that will lead to decisions that on a component level, you will maybe not choose the optimal value, but it will lead to a best value on a system level. Yeah? So that's the point. And with all this, you could reduce, for example, or delete hardware. You will be faster time to market, and we had scalability yesterday as well. You could reuse certain build blocks. You could reuse certain software stacks. You could reuse certain components. You could reuse certain approaches. And how we start this and how we did this and where we are, I would like to show you as well. So that is why we really work with connected engineering. And again, it's not AI. Connected engineering is the first step, where you really automate certain processes starting from or what you did earlier with people, handmade, not connected, or you have to send mails, or you have to send data to different people. So that is what you bring in a process, in a system, in a digital system, where you feed in all the inputs, and the inputs could be completely different. Could be an Excel sheet, could be a database, could be models, and then you have a workflow. And also here, our approach is that we use an open source system so that you could, with APIs and connection, bring in a lot of different systems, because we would not like to invent tools new. We know all that there are different companies, different people working with different tools. So you have to implement the tools they use today. Then it's also easier for all the engineers. And work then in the workflow with the different systems. And here also that could be MATLAB, that could be ANSYS, whatever, depending on that there is a defined API, what could you use, but in the most cases that is given. And then you get a certain output, what you could define and what you could really configure. And we started with different components. Originally, the first thing we did was routing from thermal systems and also from wiring harnesses, because that was in the beginning really just a package issue, a physical issue. Then we increased, started with drives, so e-motor and transmission, went to the battery storage, and later on also power electronics, and latest is the thermal system, so that we not just go in, let me say, mechanical and physical package things where you then can calculate also outputs, but that you really can go also in cooling loop layouts, designs, and optimize this then with the processes. And now just showing you some points, and it's just, I will go through fast. It is more or less always then the same approach for the different kind of models here in the case for the battery. So as I said, so you have certain use cases, you have inputs you could define or you have available. Quite probably that is not always available, and also is depending on in which phase you are. For sure, if you are in an early concept phase, you have assumptions, but you could work with. It's a good baseline, but you could can evaluate a lot of different designs and alternatives already in the early phase, and then you could adjust assumptions as soon as they are more clear or there is a decision really fast to your project. Showing you here how it's running on a battery system with a certain package space. You could bring in different cell types. You could bring in different structure. And that's real time. Real time based on a concept phase where you really have the package space, where you have a certain data for your cells, where you have certain boundaries already defined. Real time would slow down a lot as later you are in the process and as more detailed analysis you have running in parallel or in the systems. Because you could connect this, for example, also with a structural crash testing side pole, but running this simulation needs time, so then you will not have this real time. But you get in this early phase a lot of different combinations, have already in the early phase the best and optimized concept and can work from there then to your final product. And that is where you really can gain the speed and where you could also increase your quality. And similar approach here on the inverter package and bus bars, and same situation. You could, depending on your boundaries, for sure always do package. Mechanical items are the fastest, but you could also then always consider, for example, thermal loads, thermal behavior based on the boundaries, the components in the parts, the components beside your thermal system you have, so that you definitely have not to, let me say, start with your three main ideas. Normally you go then with the best you have in your stomach. Quite probably you go some extreme version and something else. So you get really here a wide range of alternatives where you could pick from the beginning. A good setup. So you could really go in details with this approach. And that is also what I would like to mention, I will come later to this as well. So I mentioned yesterday it's a lot of cooperation needed, because you see you can go so much in detail. You can have a wide range of overview, but normally you are not able to do all this work alone. So in best case, you have this orchestration at a certain point in time. You use the different levels from a component, from a subsystem, from a system, from an application to bring it together and then focus really on a system efficiency, because there is where you have the most impact on your final product. And so that was on the engine. Just some more detail here. As I said already, you could start with a, let me say, rough workflow in the beginning, and you could then have ultimate refined loops where you really can adjust your boundaries, where you could adjust your test results, where you could adjust quite probably also different requirements you would like to bring in, changes in the program. As soon as you have your connection done, there is the speed gaining really in all this process between the single steps you normally have in a development process. And with that, I come already to the summary. So, and also where we are, because there was also AI in the name, and I said maybe that will be the smallest part. As shown, we did standardization, we did digitalization, we connect and automate already with several parts shown on the table. there is much more you can do. There's much more we would like to do. That is all rule-based so far, so there is not too much AI in, and I really bring this always up because there's too much confusion often in this field. Depending on calculation times, and so you could also use their certain artificial intelligence methods, but in the most cases this is rule-based. But the next step, and that's the important point, I think you all know and heard about things like OpenClaw, which is more or less then that you really could orchestrate single steps really based on agents. That will also change our development work much from my perspective. Maybe not tomorrow, but relatively fast. And that is the next step. I would not say, or I would not give a timing, but that is definitely what you have to go in and what you have to work. And based on this, that's then also the important point. I also use OpenClaw again. Safety and how you deal with your data is really important. So therefore, quite probably would not work with OpenClaw, but you have to think about how you could use AI and agents in your system that it's safe. And what you also have to take care is you also with the models which are available on the market, that's your baseline, but you have to train them with your domain knowledge. You have to ensure that there is no hallucination and all this stuff. So therefore we set up our calculation power or computing power infrastructure in-house for exactly this on top and domain development. So we use all the open source large language models, for example, and that is flexible. So you could exchange from one day to the next based on who is the best right now. But then you run it on your own system where you could ensure that there is a safety given, that there is a program and confidentially given between different projects, for example, and have with that the solution that you could use. Let me say the global knowledge about and models which are available, but ensure that your domain knowledge and your know-how stays inside, and you also could work then with the different partners. And finally, again, now a complex picture, and what I said, so most things are complicated, that's easy, but complex, it gets with, if you go in pricing, if you go in geopolitical discussions, if you go in all these things, if you connect, for example, grid with different applications or different requirements. And so what I showed is really the beginning. So there's already a lot done, but it's really the beginning. There's so many more you can do. And the question you should ask, and we ask ourselves, is where would you like to be in this game in the future? And where you would like to give your added value. And finally to see it in product. And that's it from my side. Happy to answer questions. Feel free to connect, contact data, or LinkedIn, as you would like. Thank you.